Hey guys, Mr. T here, another video, this one on range, quartiles and interquartile range. So we've been talking about measures of center, but now it's important to talk about the measure of spread of data sets, as the size of the spread tells you about the consistency of the data values, unlike the measures of center that just tells you where the middle is, okay? So the range is the simplest measure of a data spread, and is also the most unreliable because it just involves two data values, the smallest and the largest, and you find the range with range is equal to the maximum data value, take the minimum data value. So the biggest number in the data set, take the smallest number. Next idea is the idea of quartiles. So the median of a data set divides it into two halves. So imagine this is a data set here. The median is the middle number, and so you have the lower half and the upper half divided into two. The medians of each of the halves are known as quartiles. Why? Because they halve the halves again and divides the data into quarters. So if I found the lower half and the upper half, because I've divided the data set into two through the median of the two halves, so the median of the upper half, median of the lower half, is going to divide the data into quarters, as you can see here. So you've got one section, 3.5, another section, 3.5, another section, another section. Okay? So these have special names, but each section is known as a quartile, okay? So the median of the lower half, so this is the lower half here, the median of that, the lower median, is known as the lower quartile, or Q1. So that's what I've indicated there. So what is special about that? 25% of the data is less than Q1, so if these are all the data and they're in order, 25% of all the data is going to be less than, or I should say less than or equal to, the lower quartile there. What does that also mean? 75% of the data is more than or equal to the lower quartile. So 75% of the data is there. So what you can see is that each of these divisions represents 25% or a quarter of the data, which makes sense because they're called quartiles. The median of the upper half here, so this is the upper half, we found the median of that. 75% of the data is less than Q3, or less than or equal to Q3. So 75% of all the data, 3/4 of all the data is going to be less than the upper quartile, and 25% of the data is going to be more than that. Okay, so upper quartile or Q3. This brings us to the idea of interquartile range. So the interquartile range, which is abbreviated to IQR, is the range of the middle 50% of the data. It's better than the range straight up, as it's unaffected by extremely high or low data values that could be outliers. And so you calculate the interquartile range using, interquartile range is upper quartile, Q3, take away the lower quartile, Q1. So the best way to go through and show you how this works is with an example. So if we find the range, median, Q1, Q3, and interquartile range of the following data set, it's already in order, saved me some time. So let's find the range using the formula that I've given you. Range is max, take min. We already know the max is 15 because it's in order, and the min is 1. 15 take 1, 14. Done. So the range is 14. We need to find the median. Median is n plus 1 over 2. Th number, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 20 numbers. 20 plus 1 over 2. 21 over 2. 10.5 number. So it's going to be between, therefore, median equals mean of 10th and 11th numbers. So the 10th and 11th numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 10 and 11th number. So it's going to be 6 on 6 on 2, 12 on 2, 6. So the median is going to be 6. And now we have to split the data into halves again to find Q1 and Q2. So in this case, If your data set is an even number, and so the median is between two, then your upper half is inclusive of either side. So it includes that 6. And includes that 6 for the lower half. So that's upper, that's the lower. That is slightly different to, that's different to if the data has an odd number of values. See how here the upper half does not include the median? The lower half does not include the median, so just be wary of that when you're finding them Q1 and Q3. For our purposes, the way that we're going to do it is for odd numbered data, so here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 bits of data, the median is not in the upper half and it's not in the lower half. That's how you're going to find it. So I've shown both examples here. So Q1, we're going to find the lower median. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. So the lower median is going to be between those two. So Q1 is going to be 4 plus 4 on 2, the mean of the two numbers that the median is between. It's going to be 8 on 2, it's going to be 4. Q3, so there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers again, so it's going to be between the 5th and the 6th numbers, so the upper median is going to be there, or Q3 is going to be there. It's going to be between 9 and 10, so 9 plus 10 over 2, 19 over 2, it's going to be 9.5. So Q1 is 4, Q3 is 9.5. And then interquartile range is the last thing that we're trying to work out. IQR is Q3, take Q1, is 9.5, take 4, is going to be 5.5. So that is how you quickly work out the interquartile range, the different quartiles, that sort of thing. Hopefully that helps you out, and I will see you in the next video.